Okay, today we were doing an differential item functioning in R. So an item is differential item functioning. It has diff when subjects from different groups with the same ability level have different probabilities of answering the item correctly. It can lead to a biased measurement of ability because the measurement is affected by nuisance factors. There are two methodological approaches for the diff detection methods. You can rely on an IRT model, or you don't have to rely on an IRT model. When you're doing a diff, you should consider the number of focal groups. So you'll have referent groups and then focal groups. The methodological approach, so IRT or non-IRT. The type of DIF effect, so either uniform or non-uniform, and whether or not the item is purified, so item purification is used. IRT methods can be used to detect both uniform and non-uniform diff. So methods that rely on IRT can detect both uniform and non-uniform, but the 1PL can be used only to detect a uniform diff, while the 2 and 3PL models are suitable for both uniform and non-uniform diff. They're able to identify them. So looking at what I did, I first installed and libraried the packages. LTM and diff-R are used to run the differential item functioning, while ggplot2 is to plot the results. I then downloaded the dataset from the article that you gave us detailing how to use the diff-R function, and I looked at it just to make sure that it was correct, and then I renamed it into a new dataset, organizational so like engineering, and so that would be the department, and then I got rid of the anger variable because it was no longer necessary. So then I looked at the data just to make sure to see what it looked at. Then I recoded the names because they were all like different than what I needed. And so I recoded them into org-eng, which was the name of my data set, and these are the new variable names. And then I looked at it. So it's right here. So as you can see, gender is at the end, which is actually the focal, what I'm comparing. So then I looked at the summary of my data set, which is just the descriptives of each item. So then I actually ran the Lord's test. And so what I'm doing here is I gave employees a general mental ability test, and I'm trying to see if the results are affected by gender, which I showed you, as opposed to ability. So I first looked at the diff using the Lord's test, which I just ran. And it's a uniform diff effect test under the IRT framework that works with only two separate groups within a data set. Some tests must have more than two groups. So then I actually plotted the results, which is over here. And as you can see, it found items 6, 16, 17, and 19 to have differential item functioning. And those are the ones in R right here. That's chi-square. So there are a lot of different tests that can be used to test for diff. There's about 9 or so right now, but there's a lot of packages within R you could use. So I used the DICO diff function to actually compare the results of using multiple tests to look for diff. So I put in Logistic, Lord, and Raju. This is my data set, the group that we are looking to see if it actually discriminates or creates two different things based on gender, not ability. So that's gender. Focal name, there's only one of them. Purified just means that we did item purification and we want no more than 20 iterations. So this, once again, is going to show me what it detects when using all three methods. And so when you look at it, you can see it says no diff all the way across, but where it says diff, it is actually all the way across. So all three methods find it. And while it does find it for 6, 17, 16, and 19, as it did before, it also, in addition, finds it for items 14 and 20. So this means that these items have different probabilities of people answering them correctly based on whether they are male or not. And that does not take into account their ability. Thank Thanks for coming to my TED Talk. Have a great day.